Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us start with the paragraph questions. So we have got two paragraphs, 1 and 2. So let us start with the paragraph 1, which contains two questions, 33 and 34. So we'll start with question number 33. Students, the question is, this is the paragraph 1, which has two questions. First, let us read the question. Consider a simple RC circuit. There is one R and one C, capacitor and resistor. In figure 1, process 1, in circuit, the switch S is closed at time t equals to 0. So initially you close the switch at time t equals to 0. This is the process 1. And the capacitor is fully charged to voltage V0. Obviously this is V0 that is applied here. So it is fully charged, V0. That is charging continues for time t greater than RC. The time is much greater than RC. RC stands for the time constant. So that means for a very long time. In a process, some dissipation occurs. That is the energy lost. That is in the form of obviously heat. The heat loss is this, occurs across the resistor. So there is loss of heat in here, heat loss. The energy lost in the form of heat. The amount of energy finally stored in the fully charged capacitor is EC. So the final energy stored in the capacitor for time t much greater than RC is this. This is process number 1. And in the process number 1, this is the question. So we'll discuss about the process number 1, and in the next question we'll discuss about the process number 2. So this is the process number 1, this is the process number 2. Okay, let me read that. In a different process, the voltage is first given set to V0 by 3. So it is not V0 in the first second process, it is V0 by 3. Maintained for a charging time t greater than RC. Then the voltage is raised to 2V0 by 3. So initially it is V0 by 3, then 2V0 by 3. Without discharging, so the charge, this is continuously being upgraded, the voltage is upgraded without disconnecting, without discharging the capacitor, and again maintained for a time much greater than that. The process is repeated to one more time by raising the voltage to V0. So from V0 by 3 to 2V0 by 3, then 3V0 by 3, that is V0. So voltage is gradually increased in steps, and the capacitor is charged to the same final voltage V0. So finally in the second process we are achieving V0 as used to achieve in the first process. But here this is process 1, directly we are giving initially V0, but here in steps we are increasing the potential to V0. These two processes are depicted in figure 2. Here the voltage diagram, this is time. The voltage in the process 1 is constant throughout this time, whatever time, the same voltage V0 is maintained. In the process 2, the voltage is initially this, then in steps it is increasing. So let us solve the question 1, that is question number 33 of which is for the process number 1. So in process 1 we have already seen that the voltage is V0. So we have the situation like this, that we have the supply is V0, There is one R and there is one C, and this is the switch is closed here. Time t equals to 0, and it goes to time t much greater than RC. This is the capacitance and this is the resistor R over there. Now the question is, the energy stored in the capacitor EC, here energy stored is EC, and the heat dissipated across the resistance, heat loss here, heat loss is ED, are related as. How these two are related? The first case. So in the first case, we know that for any capacitor, if a capacitor, parallel plate capacitor, is connected to a battery of voltage V0 or any V and capacitance C, the final voltage across the capacitor will be V, and the final charge in the capacitor, maximum charge that the capacitor can store, is C into V, CV. So depends on the voltage you're supplying, that is CV. So in this case, it is V0. So final charge, if you want, it should be, if I want final charge or maximum charge, it should be CV0. What is the final voltage? Final voltage across the capacitor plates will be V0, and the capacitance will remain C as it is. It is not going to change irrespective of whether the voltage is changing or not changing. So final charge of the capacitor is CV0, and this is the potential drop across the capacitor V0. So obviously then energy stored in capacitor is half CV square. This is the formula I can use. So here it is given EC is the energy, stands for the energy that is stored in the electrical field of the capacitor plates. This is being positive, negative, so the electric field in the capacitor will store the energy, and half of CV square. C is there, it's not going to change. V is V0, so it is V0 square. This is the energy stored. So this is one equation we have got. What about the heat loss? What about this energy supplied by this battery or the cell? Energy or work done by battery, work done by battery, or that is a energy supplied by battery, or EMF of the plates. The energy supplied is for a battery, it is Q into V. That is the formula for the energy supplied by the battery. Q is the charge that is stored in the capacitor, the maximum charge that can store after a very long time, and we have already calculated is CV0. This is the charge that can store, CV0. And if I put CV0 here, and what is V? What is the voltage that is supplied? That is V0. So this becomes that. So it is CV0 square. So the energy that is supplied by the battery is CV0 square. Out of this, energy stored in capacitor is half CV0 square. The rest of the energy went to. So this is what initially you have, and this is what finally you have. So this is the energy supplied, this is the energy stored. What is the energy? The rest of the energy is lost. The difference of the energy is lost. because the energy supplied by the battery is not stored in the capacitor. Half of that is stored in the capacitor. That means the half is lost in the heat. So heat produced in the resistor is work done by battery minus energy stored in the capacitor, that is half C V naught square. This heat produced is represented in the question as ED. Heat loss is ED. So this is ED. This is equation number 2. Now our aim is to compare the energy stored in capacitor EC with energy lost in the resistor in the form of heat ED. We have to compare these two. ED is coming out to be half CV naught square, and we have just calculated here EC is half CV naught square. So what we are getting, EC also from 1 is half CV naught square. This is equation number 1. How they are related? Both are same. EC is ED. So finally what we are getting is that the value of EC is same as value of ED. Whatever energy the capacitor can store, the same amount of heat energy is lost in the form of heat. So if I see the option EC equals to ED, so this is the correct answer because we also got EC is ED. So in the process 1, this is the answer. The option number 1 is correct. Okay, thank you.